Sir, are you able to hear my voice? Are you able to? Oh, yeah, okay. Okay. Hello, good evening, everyone. This is Dr. R. Sanjal Kumar, Assistant Professor from Institute of Road and Transport Technology. Um, uh, Department of Electronics and Communication Engineering, Institute of Road and Transport Technology. Here I am going to give you a talk on the machine learning using Scikit-Learn. Okay. Uh, now the voice is audible, sir. Okay. Um, Hello, good evening, everyone. This is Dr. R. Sindhil Kumar, Assistant Professor, Institute of Road and Transport Technology, E-Road. Welcome to the Chennai Python Meetup, July Meetup group. Here I am going to give you talk on machine learning using Scikit-Learn. What are the Python libraries necessary for the machine learning using Scikit-Learn? Python 3.7 and above, I am here using Anaconda Python 3.8, Matplotlib, NumPy, SciPy, Pillow and Scikit-Learn. If you are using Anaconda Python, no need to install all those things. It will come by package. Matplotlib, NumPy, SciPy, Pillow, Scikit-Learn, all are come by a single package. So no need to install separately in Anaconda Python. Here I am using Anaconda Python 3.8. So what I am going to do here, here I have taken some 13 or 15 samples. I have taken the river water images, and the river water images I am going to classify the river water images using the machine learning technique, right? What I am going to do here is I am classifying the river water samples into 4 classes. One is first one is if the river water has no contamination, and no contaminated river water. If the river water is lightly contaminated river water. If the river water is mildly contaminated river water. If the river water is highly contaminated river water. So what I am going to do here is I have taken 13 or 14 samples of river water. No contaminated river water, that means more or less pure water, and highly contaminated river water, mildly contaminated river water, lightly contaminated river water. I am going to classify these contamination of river water, that is the images of river water, using machine learning technique, right? So what I am going to do here, collect the water sample images, and the second step, find out the principal component analysis of each collected image samples, and encode image samples using encode the image samples, and classify the image samples using KNN classifier. The classification accuracies are calculated for different number of numbers. Results are plotted, right? Okay. So the principal component analysis and KNN classifiers and label encoder all are come by built-in package in what Scikit-Learn machine learning library. So no need to write program for principal component analysis and KNN classifier and label encoder. It will all are available as a built-in package in Scikit-Learn. So the sample of collected river water samples here displayed. Non-contaminated river water sample. Under this non-contaminated river water sample, 3 samples are collected. Lightly contaminated river water sample, 3 samples are collected. Moderately contaminated river water sample, 3 samples are collected. Severely contaminated river water sample, 4 samples are collected. Total I have 13 images. 13 images. Non-contaminated river water 3, lightly contaminated river water 3, totally 6, moderately contaminated river water 3, totally 9, severely contaminated river water sample 4 samples. So totally I am having 13 image samples. So and derived principal components for all the 13 images. The first figure shows the top first principal components of all the 4 classes. The first classes is non-contaminated river water, second classes is lightly contaminated river water, third class is mildly contaminated river water, and fourth class is severely contaminated river water. And the second figure shows the this one. The second one shows the second most highest principal component of all the 4 classes, and the third one shows the third most principal component of 4 classes. What do you mean by principal component analysis? What do you mean by principal components? These principal components are nothing but the eigenvectors, topmost eigenvectors of the image matrices, right? Okay, the principal components are nothing but topmost eigenvectors of the image samples collected, right? So in the class 0 non-contaminated river water image ID, we under this non-contaminated river water I am having 3 image samples, and the principal component, topmost principal component has highest value 0.639, and the next topmost principal component has the value 0.699, and the third one has 0.594. So what is PCA1? Top first in the sense highest eigen value, right? Next highest eigenvector value value equal to 0.063609, and third one 0.594. Similarly, you have to collect all those, you have to find out all the principal components of all the 13 samples. Class 0 has 3 images I1, I2, I3. Class 1 has 3 images I4, I5, I6. Class 2 has 3 images I7, I8, I9, and class 3 has 10, 11, 12, 13 images, right? Okay, so the PCA1 is the topmost eigenvector. Next topmost eigenvector is PCA2, and the next topmost eigenvector is 0.59 PCA3. Sir, whether the voice is audible? Sir, whether the voice is audible? Yeah, right, okay. So I just simulated using the Anaconda Python, and if the class 3 if the result is displayed here is 3, it indicates that the river water sample is severely contaminated. If the result displayed here is 2, in the sense it is moderately contaminated river water. So what is 0 and 1? If the result displayed is 0, it belongs to class 0. Class 0 in the sense non-contaminated river water. If the result is 1, then the 1 belongs to class 1. What is class 1? Lightly contaminated river water. So if the result is 2, moderately contaminated river water. If the result is 3, classified result is 3, it belongs to class 3. What is class 3? Severely contaminated river water, right? So here I am using K nearest neighbor classifier, machine learning algorithm K nearest neighbor classifier. If the number of neighbors equal to 1, I am getting 100% result, and false alarm, that's the misclassification, equal to 0. If the number of neighbors equal to 2, I am getting 76.92, and false alarm equal to 23.08. If the number of neighbors equal to 3, I am getting same result 76.92, and false misclassification 23.08. If the number of neighbors equal to 4, I am getting the recognition accuracy, correct classification accuracy 69.23%, and false alarm misclassification 30.77%. So here the graph shows recognition accuracy and misclassification or false alarm for different neighbors. If the number of neighbors is equal to 1, I am getting 100% recognition accuracy, false alarm equal to 0. If the number of neighbors equal to 2 and 3, I am getting more or less 76%. If the number of neighbors equal to 4, the recognition accuracy approximately equal to 60 something percentage, and the misclassification equal to this much. So if you want more about machine learning using Python, Python Raspberry Pi, you refer this my YouTube video lecture on machine learning using Python plus Raspberry Pi, part 1, part 2, part 3, and machine learning based classification of contaminated drinking water using Raspberry Pi embedded system and IoT device. The link is given in the fifth link, right? Right. So the Python program, first import matplotlib and numpy and fill for image processing application, and numpy for calculations, and Scikit-Learn is the Scikit-Learn machine learning algorithm. Here I am using PCA library from the Scikit-Learn and also label encoder from the Scikit-Learn, right? Read all the 13 samples. PCA equal to PCA2. I am going to find out the eigenvectors. First to find out the principal components of image 1 and save it in a text file and rearrange the top short all those files and rearrange the topmost first PCA in I11 and second PCA in the I12 and third PCA in I3 and similarly derive the principal components of image 2 and save it in a text file I2 underscore short.txt and rearrange that so that you can store the topmost principal component in under I2 underscore 1 and the next topmost value in the I2 underscore 2 and the third topmost principal component I2 underscore 3. Similarly, I calculated principal components, topmost 3 principal components of all the 13 image samples and stored it in the variables first eigenvector values of 13 samples, second eigenvector, topmost eigenvector in second underscore EIG, third topmost eigenvector in third underscore EIG, and I find out the encoder value in feature 1 underscore encoder and feature 2 underscore encoder and feature 3 underscore encoder. Feature 1 underscore encoder is the label encoder value of the first eigenvectors. Feature 2 underscore encoder is the label encoder output of second eigenvectors, second topmost eigenvectors of all the 13 image samples. Feature 3 underscore encoder is the label encoder value of the third eigenvectors of all the 13 image samples and the target fixed. First 3 belongs to the class 0. So assigned 1 1 1. Next 3 images are correspond to the class 1, assigned value 2 2 2. Next 3 belongs to the class 2, assigned 3 3 3. And the last 4 belongs to the class 3, 4 4 4 4. Last 4 images, right? So I fixed the target. And all the features of encoder features are stored in the features variable. And I am using the k nearest neighbor of the neighbor algorithm from Scikit-Learn machine learning algorithm from Scikit-Learn. If the number of neighbors equal to 1, what I am going to get, right? This is the classification method. Recognition accuracy, how faults are calculated, right? So I am going to run the my Python program, right? This is the Python program for image classification using machine learning algorithm using the Scikit-Learn Python library. Import matplotlib till the same program displayed in the PowerPoint presentation, right? Okay, read all those images, find out the principal components of all those images, label encoded all those eigenvectors values, and then store it in first eigen, second eigen, third eigen, and then find out the encoded values, and then right use k nearest neighbor classifier, right? Recognition accuracy calculation, right? Number of images, the j is nothing but number of images properly recognized out of 13 images. So j divided by 13 into 100 gives you the recognition accuracy, and recognition accuracy is stored in if 13 minus j gives you the number of misclassified images. Divided by 13 into 100, you can get false alarm, misclassified images, right? Run this program. This one is the spider. Spider mainly used for data science application, machine learning application. This spider come by built-in packages as a built-in package in Anaconda Python. This spider consists of all the necessary libraries for machine learning and data science applications such as pandas, Scikit-Learn, Seaborn, Matplotlib, NumPy, SciPy, Pill for image processing. If you want to do complicated image processing, you have to install separately OpenCV package in Anaconda Python. So simple for image processing, Pill is sufficient. Pill and Matplotlib, both you can do simple image processing applications, right? Okay, so Pill and Matplotlib available as a built-in package in Anaconda Python. Spider specifically used for machine learning and data science application, right? Here the number of classifiers I have chosen equal to nearest classifier classifiers equal to 1. I am getting 100% recognition accuracy. Recognition accuracy equal to 100%. Probability of false alarm equal to 0. If I am using number of classifier equal to 2. Around 76.92%, and the probability of false alarm this minus 100 equal to 23.07%. Suppose if I am using number of classifiers equal to nearest neighbors equal to 4, I am getting 69.23%. 100 minus 69.23 gives you 30.769% false alarm. So how we can plot? These are already stored in the variable. Recognition accuracies are stored in the variable RA, and false alarm value stored in the variable FA. Run this. You can view the plots. Here it is. Plots variable. This one is variable explorer. If you want to see the variables here using variable explorer. If you want to see the plots, click this one. If you want to maximize this one, use the pan, maximize control pan. Maximize this. Yeah, it's not working, right? Okay, so if you want to see the plots, you can click this plot. You can view this plot of this one, right? Okay, recognition accuracy, right? So if you want to do more complicated image processing, you can complicated image processing or video processing, you can use OpenCV. And if you want to use deep learning along with machine learning, you have to install Keras and TensorFlow. So for Keras, if you want to install Keras, the backend is TensorFlow. So you have to install Theano or TensorFlow, and above that you can install Keras. If you want to do more complicated machine learning applications and deep learning applications. So that's all about today's talk. If you have any questions, you can ask me. Any questions? Any questions?
I think we have a comment from Arnavan. He says 13 samples is not enough to complete PCA.
Yeah, you need more. You need more image samples. We need 100 or 200 more image samples. Then only you can get accurate image classification. For UG students projects, just I am collected 13 image samples from the Kaveri river water in Erode in 4 different places. So if you want to do more accurate image processing, machine learning classification, we need 100 and 200 samples. For each class, we have to collect more than 100 samples. Then only we can get accurate image classification, machine learning, fine-tuned machine learning algorithm. Hello?
Yeah, thank you, sir.
Any other questions? Any other questions? The same program, one thing I want to mention it here, the program run in Spider, Anaconda Python Spider. The same program you can run it in Python, ordinary Python 3.7 or 3.8, and also in Python 3.6 in Raspberry Pi embedded kit. I tested in 3 different domain. One is Anaconda Python, another one is Python 3.7 and Raspberry Pi embedded kit, and also the same program work in Ubuntu Linux also. Any other questions? Any other questions? Any other questions? The same program runnable in Anaconda Python 3.7, ordinary Python 3.7, Raspberry Pi embedded kit Python 3.6 and Ubuntu Linux also. Any other questions? Any other questions?
I think that's it, sir.
Okay.
Should we dive more next step?
Any other questions?
Yes, sir.
Okay, right.
I think there is no other questions, Mr. Sendil.
Okay, sir.
We can move on to the next talk.
Okay.
You are now muted.
Thank you for the talk, Sendil.
Okay, sir. Thank you.